guys, I am ready to start Module 15, Lesson 1 on page 401 in your math workbooks. By now you should have done the Are You Ready quiz on page 400. So if you have not done that yet, pause the video, go do that quiz. It's really important because we're reviewing skills that you are going to need in Module 15. So, Module 14 was super short. Basically, the point of that module was just to show you that fractions mean something. Fractions represent space within an area. And yeah, that's pretty much it. And we can use fractions to describe parts of a whole, and we can compare them, which is what we're going to be doing in Module 15, is comparing fractions. So, the skills on page 400, that Are You Ready quiz, are important because we need to know what fraction pieces are called, we need to know how to use the number line, and we need to know how to use greater than, less than, and equal to symbols. So, pause the video, go take that quiz, and then come back to the lesson. So like I said, we are starting lesson 1. The title of today's lesson is Compare Fractions Using Concrete and Visual Models. Our I can statement says, I can use concrete and visual models to compare fractions. So before we even do the Spark Your Learning, I just want to preface this by saying that it's really, really important that we keep track of the fractions that we're using and the wholes that we are describing. And by wholes, I mean whole, W-H-O-L-E. I wrote this little tidbit down. It says a whole is divided into equal parts. So the whole is the entirety of something. So it's the entire circle, it's the entire pencil, it's the entire ice rink, it's the entire house, it's the entire pie. I'm just thinking of all these things. Okay, so that is what we talk about when we talk about a whole. Okay, it's just a whole entire thing. A whole can be divided into equal parts. And we learned in Module 13 and 14 that those parts have to be equal to each other in order to be called fractions, okay? A whole is divided into equal parts. We call those parts fractions. We can only compare fractions. Now this is where it gets really important. We can only compare fractions if the wholes are the same. Okay, so if you look at, I drew this on this other whiteboard, okay, these two circles are identical, and I know they're identical because I took my water bottle and I traced it. So they are exactly the same. If I take these two circles and I divide the top one in fourths, and the bottom one in fourths, okay, I can say that these parts are equal to each other. And then if I say, okay, this one is 1/4, this one is 2/4. Which one is greater, 1/4 or 2/4? Because these circles are the same, I can say without hesitation, without a doubt, that 2/4 is greater than 1/4. Now, if I take a look over at my triangle and my circle that I drew, if I divided this in half and divided this in half, if I colored 1/2 of the triangle and 1/2 of the circle, could I say that 1/2 is equal to 1/2 of the circle? And the answer is no. And that is what is so nuts. 1/2 and 1/2 Are the same fractions? Yes. They are describing, we are using the fraction to describe this whole, okay? So I'm saying 1 part of the 2 are being shaded. That is true. 1 part of the 2 is being shaded. That is also true. Are they equal to each other? I cannot with certainty say that they are the same because the wholes, the whole triangle and the whole circle are not equal to each other. So I cannot say that this half is equal to this half. Okay, does that make sense? We are going to go through this very thing through lesson 1. I just wanted to kind of preface this to you and just kind of get your mind in this frame of mind. So I'm going to come back to this later in the lesson, but let's go ahead and begin the Spark Your Learning. It says, Raphael and Frankie each paint 4 equal parts of their doghouse walls. Each wall is the same size. That is going to be a very important phrase throughout this module. Who uses more paint? Okay, so we have a picture of Raphael's doghouse and Frankie's doghouse. They both painted 4 sections of the doghouse, and the doghouses are the same, which means we have the same holes. We have the same whole thing. So that's wonderful. So if we look at Raphael, let's look and see how many total pieces he has. He has 1, 2, 3, 4, 5, 6 total parts of the doghouse. So I am going to draw a just a model of this showing 6 equal parts. I'm just doing the best I can. 1, 2, 3, 4, 5, 6. Okay, so I probably should have moved that line a little bit over, but that's okay. So there are 6 parts. He paints 4 of them. 1, 2, 3, 4. So the fraction would be 4 over 6. Okay. Now let's look at Frankie's doghouse. She has her doghouse in 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So let's draw 8 equal parts. And I'm going to try to, again, do the best I can of doing equal parts, okay? So 1, 2, 3, 4, 5, 6, 7. That was pretty close. I'm actually impressed. The top one, not so much, but this one is pretty good. Okay, so now I'm going to shade in 4 of these equal parts. 1, 2, 3, 4. Okay, so the denominators are different. We have 4 over 6 and 4 over 8. Now we have to decide, okay, we have the same whole, right? We have the same doghouse, same size doghouse, but they are divided into a different number of equal parts. Raphael's wall is divided into 6 equal parts. Frankie's wall is divided into 8 equal parts. So is 4 6 or 4 8 greater? If I take a look at this, 4 6 covers more space than 4 8. So just by looking at this bar model, I can say that 4 6 is greater than 4 8. Okay, so you guys are going to learn in older grades how to actually compare these fractions by changing the denominator and all of that good stuff. But for right now, we can use concrete visual models to show how to compare these fractions. And the important key of that is to make sure that the whole, the thing that we are dividing, is the same in both objects, okay? Same wall, same size, same size. Different parts, different parts. Same number of parts, different size of parts. Okay, that was a lot. So the turn and talk says, Toby paints 4 of 6 sections on a small doghouse wall. Nan paints 4 of 6 sections on a large doghouse wall. Toby says that he and Nan used the same amount of paint because 4 over 6 equals 4 over 6. Does Toby's statement make sense? Why or why not? Okay, let's do this. This is the same thing. We have different holes. So even though we have the same fractions, we cannot say that one is greater than the other because they are not equal. Excuse me, the areas are not equal. So I'll grab another whiteboard and draw this out. We have a small doghouse wall versus a big doghouse wall. Small, big. Both of them are divided into 6 equal sections. Oops, did that wrong. Okay, 6 equal sections, 6 equal sections. And both have 4 parts painted. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so this shows 4/6 of the small doghouse. This shows 4/6 of the large doghouse. We have the same fraction, but are those equal to each other? No, because the holes are different. The large house is larger than the small house. So even though we're describing parts, 4 parts out of 6, those areas we cannot say with certainty that they are equal because the holes are different. Okay? All right, I know that is a lot to take in. I know that is very mind-blowing. I know you might be thinking, what are you talking about, Miss Elle? 4/6 over 4 and 4/6, those are the same numbers. And I know they're the same numbers, but they are describing different holes. So we can't compare them. Just trust me, hang in there. Let's keep going. All right. Next page, it says, we're on the Build Understanding section. The Jasper City Parks Department marks off 3/4 of its south rink for family skating. In the north rink, 3/8 of the space is used for family skating. Both rinks are the same size and shape. Very important. So now we can compare them and trust what we're looking at. Use a concrete or visual model to show and compare the parts of the rinks that are used for family skating. So, I am just going to draw. It doesn't really ask me a question yet, so we'll get to that later. But it just says to show the parts that are reserved for family skating. So for the south rink, they mark off 3/4 of its area. So I am going to divide the rink into 4ths as best I can. Super accurate. Color in 3 sections. That is the space used for family skating. Now the north rink uses 3/8 of the space. So I'm going to divide the north rink into 8 equal sections. So I'm going to start by doing 4 and then dividing the 4ths in half. And I know I can do that because 8 divided by 4 is 2, or 2 times 4 equals 8. So I know I could do 4ths and then split the 4ths in half, divided by 2. Okay, so now I have eighths, and I'm going to color in 3 of the eighths. Ta-da! All right, part A. Which rink has a larger area for family skating? How do you know? Well, just by looking at our models that we drew, it is obvious that the south rink has a much larger area for family skating. So I would say south rink. And how do I know? How am I certain? Well, I'm certain because the south rink and the north rink are the same size and shape. Put that in a box. Same size and shape, which means that I could divide it, compare just by looking at it, and with certainty know that one covers more area. Okay, so that's what you'll write down on here. They are the rinks are the same size and shape, so I can trust my visual model. All right, so then part B says to compare the fractions. 3/4 is blank to 3/8. Over here it has our connect to vocabulary box. This symbol means less than, this symbol means greater than, and then the equal sign means equal to. Okay, so this one, this bottom one, we know, easy peasy. Equal sign means equal to or the same as. So this sign, one trick that I try to follow is that the less than sign is kind of like a tipped over L, right? It's like I drew L and just kind of tipped it over. I'll do it like this. L, tipped it over, and it's a less than sign. So maybe that's helpful for you, maybe not. But it is important that we have those symbols memorized. So, compare the fractions. 3/4 is greater than 3/8. Done, done, done. Okay, we're feeling okay, right? It's not so bad. It's not so bad. All right, number 2. Use the visual model to compare 4/8 and 5/8. Shade to show 4/8 and 5/8. Which fraction has the larger amount of the whole shaded? How do you know? So I have these 2 rectangles that are exactly the same. It's kind of hard to like unroll my book, but there's my 2 rectangles that are exactly the same, and they are both divided into 8 equal parts. One of them will show 4/8, so I'll color in 4 of the 8ths. Okay, and then one of them has 5/8 shaded, so I'll color in 5 of the 8ths. Ta-da! Which fraction has the larger amount of the whole shaded? How do you know? Okay, so if I just look at them, they're divided into equal parts, and this rectangle has more parts shaded. So it's the 5/8 is greater because they're divided into the same number of parts. They're the same size whole rectangle, and 5/8 is more than 4/8. So you would say 4/8 is less than 5/8. Right here. Da-da-da-da. Okay. Not too shabby. Number 3 says, Emily climbs 2/8 of the way up the climbing wall. Ryan climbs 2/3 of the way up the wall. Show how you can compare the fractions on the number lines. Label the distances. So here it's very important. We have the length of the climbing wall listed on our number line. See how the number lines are exactly the same length. They are divided into different parts, a different number of parts, but the whole, again, the whole is the same. So we can compare these fractions even though 2/8 and 2/3 are very different fractions. Okay, so Emily's she climbs 2/8 of the way up the wall. So we see that this number line is divided into 8ths. So I'm just going to count to 2. This is 0, 1, 2. That is her distance. Ryan climbed 2/3 of the way up the wall. So this number line is the same length as the top number line, but it is divided into 3 sections instead of 8. So I'm going to say 0/3, 1/3, there's my 2/3. Okay, so who went further up the wall? Okay, clearly Ryan climbed farther up the wall. So, is 2/8 greater than, equal to, or less than 2/3? It would be less than. So who climbs higher? Ryan. And how do you know? You need to write how you know. How do we know? Well, we know that the number lines show the same length as each other, and the number lines are divided into different parts, and those parts are equal, right? We have 8 equal parts up here, 3 equal parts down there. So even though our denominators are different, we can be confident, right? 8 equal parts versus 3 equal parts. Even though the denominators are very different, we can feel confident in our visual model because the wholes, the number line, is the same. They're equal to each other. Okay, does that make sense? Are you following along? I hope this is making sense, or at least starting to make sense. We don't have to crush this module right away. We know that. Baby steps, we just keep working on it. We keep practicing. If you need extra help, log into your IXL account, find a comparing fractions activity, do that. Go to happynumbers.com and try to do those activities just for some extra practice. That is always helpful. Okay, let's do our check understanding. It says, which spinner has a larger area shaded? Write the fractions. Write greater than, oh, I made a mistake. Write less than, greater than, or equal to. We gotta know those symbols. Miss L, we gotta know those symbols. Okay, so the 2 spinners are the same size. They're the same spinners, but they are divided into different parts. So this one is divided into 4 equal parts. So I'm going to write 4 as my denominator. And there are 2 parts shaded. So I'm going to write 2 on the top. Then this spinner is divided into 6 pieces, 6 equal parts. So I'm going to write 6 on the denominator. Then I'm going to count 2 parts are shaded. So do we have 2/4 or 2/6? Which one is greater? Well, since the holes are the same, I can just look and very clearly see this space is more than this space that's been shaded. So I'm going to say 2/4 is greater than 2/6. Okay. Number 2, shade to show each fraction. Write less than, greater than, or equal to. Compare 4/8 and 4/6. So we have the same size rectangles here. I'm going to color in 4 of the 8ths. And then I'm going to color in 4 of the 6ths. Okay, so because these 2 rectangles are the same size, even though they're divided into a different number of parts, I can still compare them because the holes are the same. And the 4/6 is more area is shaded. So 4/8 is less than 4/6. Number 3, compare 4/6 and 2/6. So I'm going to draw 4 on the top and 2 on the bottom. I love when the denominator is the same. It makes it very easy because very clearly 4 is greater than 2. So 4/6 is greater than 2/6. These ones are nice. It's these ones where you have to be very careful that the holes are the same so you can trust your visual model. On your own, number 4, it says, Tim compared total votes for voters aged 18 to 24. In a 2016 election, 2/8 of people aged 18 to 24 voted. In 2018, 2/6 of the same age group voted. In both elections, about the same number of votes were counted. So that's our whole. Our whole is number of votes counted. They're the same, roughly the same. In this case, with voting and stuff, if it's like 1 or 2 votes off, it's like fine. So they're the same. Our wholes are the same. In which election did more people aged 18 to 24 vote? Use a concrete or visual model to explain your answer. So we have the year 2016, the year 2018. And we have the same bar models here because the same number of votes were counted here. The same number of votes were counted. So that's why we have the same whole, the same entirety, the same thing that's being counted. So for 2016, 2/8 of the people voted. So we need to color in 2/8. So I'm going to divide this into 8s as best I can. 1, 2, 3, 4, 5. Ooh, that was not my best drawing. Okay, and then color in 2 of them. Okay, and then 2018, they said 2/6 of the same age group voted. So now, instead of dividing into 2/8, I'm going to divide into 2/6. So 1, 2, 3, 4, 5, 6. Okay, and color in 2 of those. Okay, so which year did this age group, did more people from this age group vote? Was it in 2016 or 2018? Well, if I look at it, I can trust my visual model and trust where I drew my, I shaded in my parts because the holes are the same. And so you can see that 2/8 covers a less area than 2/6. So 2018 was the year that more people in that age group voted. Number 5 says, Patty walks 2/4 mile on Monday and 3/4 mile on Tuesday. Show the distances on the number line. On which day does Patty walk a shorter distance? How do you know? So we're looking for the day that she ran a shorter distance, and then we got to say how we know. So on Monday, she walks 2/4. Oh, I guess she didn't run. She walked. So she walks 2/4 mile. So let's see, our number line is divided into fourths. Okay, so this number line represents 1 mile. That's our whole. And she walked 2/4 of that 1 mile. So I'm going to count that 0/4. This is 1/4. This is 2/4. This is 3/4. On Monday, she walked 2/4 miles, so I'm going to put an M for Monday at 2/4. On Tuesday, she walked 3/4 a mile, so I'm going to put a T for Tuesday. Which day does Patty walk a shorter distance? What's shorter, 2/4 or 3/4? 2/4 is shorter. So she walks a shorter distance. This is what you're going to write down. She walks a shorter distance on Monday. And I know because I'm using the same whole, my 1 mile. Okay, and 2/4 covers a shorter length than 3/4. They cover different lengths. And this one's easy because they have the same denominator. So we could say 2/4 is less than 3/4 because 2 is less than 3 because they have the same denominator. Okay, so the point of this story, point of this module, not the whole module, this lesson. The point of this lesson is to show that we can compare fractions if we have the same whole, okay? They don't have to have the same denominator. They don't have to have the same numerator. As long as we are comparing the same whole things, like we said here, as long as we're comparing these two identical things and not comparing two things that are not identical, we can use a visual model and trust it, okay? All right, so deep breath. I hope that made sense. I hope you're okay. Good luck on your homework, and let me know if you need any help at all. If you have a question, have your parents email me, call me, whatever you need. I'm here for you to help, okay? So do your best, and I'll talk to you later. Bye.